folks. Welcome to
Vector calculus.
So our most basic parabola, the one we should all know, is this one, right? The happy face looking parabola. And that parabola, of course, we know its equation. Its equation is going to be y equals x squared, right? Now, what are some of the properties in this parabola? Well, this parabola is going to have a few things, right? I'm going to use this dark green to highlight them. It has a vertex, right? That's the first thing you'll probably see. Vertex is kind of, you take this vertex, you can move around the parabola, right? That's all the vertex really does. It's just putting the parabola in different places. It's translating the parabola. We also have a focus in the parabola. Now, you're probably thinking, what's the point of this dot? What does this dot do? I'll show you in a minute. This dot is associated with this line. This line that we like to call a directrix. And why is this line, directrix, and this point, the focus, so important? It's important because together they capture one of the most important properties of a parabola. And that property is, if you pick any point on the parabola, pick a point on the parabola. Go ahead, try picking a point. Let's say I want to pick this point. That point is maybe, I don't know, maybe it's 5 away from this. But because it's 5 away from that, check it out. It also has to be 5 away from this one, from this line. In fact, that's what defines a parabola. That's how a parabola is created, using a compass and a straight edge with this property. I can pick another point. Let's say you pick this point. This point is probably 3 units away from the focus, but that means it would also have to be 3 units away from the directrix. And now you're starting to get a kind of idea of why this is so important, right? Pick another point. Pick another point. Let's say you pick a point right here, underdog point. Maybe that's 2 units away from the focus.
Hi.
Then it would also have to be 2 units away from the directrix. Now you start to see how the parabola is constructed. Now what I'm going to do is actually show you how to construct a parabola with this principle. Let's go ahead and check it out. Alright folks, so now what we're going to do is go ahead and we have a few things going on here. We have the actual center of the directrix, right? We're going to have the focus of the parabola. I don't know, maybe we can put the focus perhaps just a few centimeters off. So this right here is my focus, and of course the vertex of my parabola is going to be right in the center of these two. I'll just guess, maybe it's somewhere here, and that's going to be the center, maybe the vertex, right? Now what I'm going to do is just make equally spaced points, right? Just equally spaced points on my actual piece of paper right here. So hopefully everyone can see this, and I'm going to make equally spaced points. So let's put a point at 3 centimeters, 4 centimeters, 5 centimeters, 11 centimeters, 12 centimeters. Now, I've got some equally spaced points, and now let's construct some lines. And of course, drawing lines is pretty easy, especially with straight edge, right? So let me make sure I've got my line aligned the right way. So here's my first line. Let's move this over. Here's my second line. Okay, so I've got all of my lines in ascending order, folks. Now what I'm going to do is actually use my compass to draw some circles, right? And these circles, the intersection between these circles and these lines is going to form the actual points on the parabola. So let's go ahead and check that out. So I'm going to take, let's call this point 1, let's call this 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to take the distance from C to 1. So let's go ahead and check that out. What's the distance from C to 1? That's going to be right about from here to here. From here to here. C to 1 is going to be from here to here. And I'm going to take from C to 1, which is this distance basically, and take the center of my compass to be at F. So let's take that center to be F. Okay, I'm just going to show you how to do 1, and then I'll leave you guys with the time-lapse footage. All right, so let's put on the red pen and look at what we have. We have our first arc, and these 2 points are gonna be the first points on our parabola, folks. These 2 points right here. Now we're gonna repeat the same thing, except now instead of taking the radius to be C1, I'm gonna take it to be C2. So something like this, okay? So I'm gonna take this point, I'm gonna put it right over here so it's centered at F, centered right there at F. Okay, it's centered right there at F. And now I'm gonna take F as my center and this as my radius, and I'm making my arc. All right. Let's see where we land. And we landed right in these 2 points, ladies and gentlemen, on these 2 points. Alright folks, we're now ready to finally draw our parabola. We have all the necessary points, and let's go ahead and see if we can actually construct our parabola, okay? So, we're going to begin drawing our parabola. Alright folks, now let's go ahead and draw the parabola starting from the vertex, okay? Let's see if mathematics actually works. And there you have it, folks. Ladies and gentlemen, we have just constructed a parabola. Thanks for watching. Let's go ahead and keep checking out the math. Alright, so we just found out how you actually construct a parabola. But what's the equation for a parabola? To check that out, we're going to start with the most basic of parabolas. And hopefully you know the equation for this one. It's going to be y equals x squared. But we don't want that kind of equation. We want a more general equation, if you will, that encompasses all of the properties of the parabola. Okay, and what properties am I even talking about? Let me show you. Well, remember that we had a few of these properties. Number one, we had the directrix, right? The directrix just going along peacefully like a line, and we have the focus right over here, and we know that every point on the parabola is equidistant from both the focus and the directrix. Okay, so we need an equation that encompasses that. We also need an equation for the axis, right? An equation for the focus, the directrix, all of that. We need an equation for that. Okay, so what can we do? Well, first let's label everything we have. We have the focus here, F, we have the vertex here, V, and we have the directrix here, D. So let me just give you the equation. It's going to be y minus k is equal to 4p times x minus h squared. Okay? Now, what's the location of my focus? What's the location of my focus going to be? Well, the location of my focus, think about it. Let's think about this before we actually write anything down. I want the location of my focus, I want the location of my vertex, and of course I want the location of my directrix. What a nice little word. Well, first let's start with the vertex, maybe the easiest of them all. The vertex is going to be located at h comma k. And you can see that just by looking at our equation. Look at h, look at k. So my vertex is going to be h comma k. My focus is just going to be above my vertex. And how much above? Well, how much above is my focus from my vertex? It's going to be p units above. Right? So what's the equation of my focus going to be? Well, it's simply going to be my vertex, but it's going to be pushed up a little bit. Pushed up by p units, right? So it's going to be k plus p. What about my directrix? What about this line right here? Well, this one is, even though it's not drawn to scale, it's going to be p units below. It's going to be p units below my vertex. So this right over here, that's going to be p, right? So my directrix is just going to be h comma k minus p. But wait, that's not an equation, even though this is a line, right? So we don't want a point for this, we want a line. We want an equation. So we're going to write y equals y equals k, I know that doesn't look like k, but you gotta accept it for now, y equals k minus p. That right there is the equation of the directrix. Okay, so we just understood how the formula for this kind of a parabola works. But what if you have a kind of right to left parabola, something weird, something like this? You're going to be stumped if you get that on the test, right? So here's the solution. Think about it as just changing or rotating the original parabola, right? So what's going to happen? My focus is going to come up inside. Okay, my directrix is just going to be right here. My axis is going to go through this, and of course my vertex is going to be here. So I've got my focus, my vertex, and I've got my directrix right there. You know what? It's weird if I write it like that. So let me just write it straight up. Okay, now I've got everything. Now I want the equation for this. Well, what if I write the original equation? Y minus k is equal to 4p x minus h squared. But no, this is rotated, folks, so we need something to know that it's rotated. So we change this to, and we bring it over here. That's it. That's the equation of this guy. And what's more, what's even better, we can find the equation of the vertex, of the directrix, of the focus. So let's write those down. Focus, vertex, and I'm afraid we're running out of space, but I think we can manage directrix. Okay. Now, what's the equation of my focus going to be? What's the equation of my focus? Well, my focus, you see, is just to the right of my vertex. So I'm going to take my vertex, which is of course always going to be h comma k. I'm going to take the point for my vertex, and I'm going to shift it to the right. Shift it to the right by p units. So it's going to be h plus p comma k. What about my directrix? Well, what's the equation of my directrix going to be? Well, hopefully you see down there. If you don't, let me just tilt the camera down. But what's the equation of my directrix going to be? My directrix is simply going to be y, or rather in this case x, is equal to h minus p. And why minus p? Because you see it's shifted to the left. Alright, ladies and gentlemen, so that right there has been a deep dive into parabolas. In the next lecture, lecture number 4, we're going to start investigating some problems about parabolas. So how do you find the focus of a parabola given the vertex? How do you find the directrix? How do you find the major, the minus axis, the lactus rectum, if that's what they call it. Alright folks, we'll check you out in lecture number 4, and that's the end of lecture number 3 of vector calculus.